Alright folks, let's just dive in, shall we? Come in from the top. This is my first stream in a while actually, and I'm not even sure if my PC is able to keep up very well, but I'm in the middle of designing an audio circuit right now for a RetroPie. So some of you may have seen these kind of portable emulators that play Super Nintendo games and this kind of thing, and some people have made them using Raspberry Pis and made them portable. I'm trying to do the same thing. I did one last year for my son, and I've done a bunch of videos that I'll post below when I eventually get around to posting all of this. But the idea is my son took this thing on an airplane with him, right? And it looked like it was a bomb, for crying out loud. You know, big screen and all these electronics and wires inside. But it was hooked up so that the loudspeakers were either plugged into the headphone socket on the Raspberry Pi, or if you unplugged it, then you could plug in your headphones. There was no real volume control other than that was inside the software, which is a real pain. Pardon me, I've got my dog here as well. Guinness. Aye. So let me turn this down just a little bit. There we go. So let's come back to thread. My wife was traveling with my son. I get his phone call saying, how on earth do I turn down the speakers on this thing? It's way too loud. And I was like, oh, I didn't put a volume control on there. And so that's what this task really is all about, is getting a volume control and getting it up and running. So give me a second here. Alright, sadly, I actually have a mechanical keyboard here, which I've learned very, very quickly is like the worst kind of keyboard for traveling with. And so as such, forgive me, I'm going to try and keep that as quiet as I can, and we'll go from there. So what you guys can see here, this is the start of the circuit here. In fact, let me go back one step and show you some of the tools I have in Eagle. So Eagle's my weapon of choice here, and I haven't actually updated. That's interesting. Hold on. Is my stream not working all of a sudden? Bear with me, guys. Typical stuff. Let's maybe comment. Notifications. Apparently no one can actually find my... Oh, there we go. There we go. Hey, how's it going, Sion? Nice to see you. All right, fantastic. You had me really worried then for a minute. So let's jump back to Eagle. Eagle's my weapon of choice. Some people like KeyCAD and all that kind of fun stuff. But let's have a quick look here. So I'm to the trusty cup of tea, by the way. You can't be an engineer without a strong affinity for tea. Here are some of the tools I've built into to Eagle here. So this is Eagle 7. This is the last one you could buy in perpetuity, wherever it was, before Autodesk came along and ruined everything. But what I have is a couple of little scripts that I run, and I've done a video on these on YouTube. I'll post to those again below. But I can hit this, okay, and I can say, okay, author. So I could just change this if I wanted to Orochi, or I could put in my initials and describe the project, which is headphone amplifier. Forgive me for the keyboards, I will replace it. But the headphone amplifier, and that immediately changes details down to do with the project. See, so project headphone amplifier, and then if I want to change each page individually, I can actually go into attribute, which is one of these glorious ones. Where is attribute? Attribute. Come on. There we go. And I can actually change every page description then to be like, you know, block diagram, for instance, right? And then that will update over here as well. So there's a lot of cool little tricks and tools that we can use using this. And so, but anyway, I already kind of got a head start here. let's dive into that. So I'm going to open, no, I don't want to save that. And let's open a schematic, RetroPie amps. And you can see here, I started working on this last night, and I then, very quickly started realizing I haven't got libraries. Gah, so the 2 amps I had in mind, let's see if I can show you those real quick. So I'm a big fan of buying modules. And the reason I like buying modules is not because they're actually any good, it's because they come with all the components you need. So if you copy a lot of the schematic but change 1 or 2 things, when you buy a cheap module, guess what? You're getting most of the parts you need, right? So you don't have to buy a reel of caps and a reel of parts and so on. So one of the parts I'm really quite fond of for the amplifier side of the house is this PAM 8403. Let's just wait for this to load. So it's a 3-watt Class D audio amp. It's what I used in the original board, but I actually used a module. Now, the nice thing about this is, A, it's Class D, so it's going to be low power, and it's also got a wonderful shutdown pin. Now, the modules you buy from China don't use a shutdown pin, which is just a wasted opportunity. All I can think to myself is that whoever's designing these modules in China doesn't really understand what they're doing. They're just literally copying a reference schematic like this. I've seen it with some of the old DACs I did when I worked at TI. I've seen it in other places as well. They just copy blindly without even thinking it through. So what I want to do is, the headphone amps always go in because if the headphone isn't plugged in, you're not burning any real power there. And then the speaker amp needs to disable itself when you plug in a headphone. Kind of very similar to what your notebook PC does. And so let me see if, so there's a pin here, shutdown pin, here we go, which I can tie to some logic in the switch, and Bob's your uncle, fanny's your aunt, job done. You can be up and running very, very quickly. And so that's the headphone amp, sorry, the speaker amp I want to use. And just for reference here, because this is something that finally dawned on me, we want to look at the idle current consumption on this guy. And so output power, total harmonic, power supply rejection, quiescent current. Okay, so I'm going to be running this either from a 5-volt rail or from a 3.7 VBAT rail. Ideally, it's going to be like a 3.7 to 4.2, so I'm going to take it from the battery. And then if the battery is being charged from a separate circuit, it'll sneak up to 4.2, but it should be fine. And so under those conditions, we're looking at about 10 milliamps. So, I really want to shut this down when it's not running. 10 milliamp, if you're running from a 2000 milliamp battery, okay, it's 200 hours, 200 hours of life, but it's still pulling away from what could be driving the screen, could be driving everything else. Yeah, Adam, I see it's not a TI amp, okay? TI doesn't do something this small on a little board that I can buy in China for like 35 cents a piece. When TI does, I'll definitely consider it, but for now I don't need 160, 200 watt amplifiers that are portable. So the shutdown current here, and this is something to really look at here. They're saying when it's shut down, it's less than 1 microamp, which is basically off. So love that. A microamp is mouse farts of power compared to anything else. All right, so that's the speaker amplifier. Now for a headphone amplifier, I saw that a popular one on AliExpress and so on is this TDA 1308. TDA 1308, and let's have a quick look. So here's a TDA 1308. It's a Class A/B stereo headphone amp. There aren't actually that many Class D headphone amplifiers on the market. They're actually really, really hard to find. And one of the main reasons for that is the noise that typically comes with Class D and things like pop and click. Class A/B is a lot easier to control a lot of those things, but thanks, Theo. I've lost thread. I gotta practice this. Class A/B amplifier is a lot easier to control. You get a lot better power power supply rejection ratio as well as you go. So this was a little device I saw, lots available. It runs down to 3 volts, which, you know, I need VBAT to be between sort of 3.6 and about 5.5 worst case. So this fits this beautifully. Supply current, we're looking at about 3 milliamps, 5 milliamps worst case. That's still a little bit high, but considering that this is going to be on only when, you know, the display is on, when everything else is on, really I'm like, this is, you know, 3 milliamps compared to, you know, having LEDs on in my product has gone to 10 milliamps for crying out loud. So again, mouse farts of power. We can consider, you know, the other one shut down current to be cockroaches farts of power. I don't know. You know, specifications for this, the total harmonic distortion, it's good enough. You know, I don't expect people to be listening to hi-fi products on this, and, you know, the emulators that we're playing were never really more than 8-bit anyway. THD, very similar. Signal to noise ratio, that's going to be quite nice. So, you know, 100 to 110, put it in perspective, CD quality audio is about 96 dB. So up at 110, it's below the hiss and the noise floor is going to be very, very low, which we like that. Alright, and so if you look at the actual pinout of this, it's basically an op-amp. Really, really simple. It's a pity actually that there isn't a shutdown pin for this. But what I'll do is I'll tie VDD, which is the power rail, to the same power source as the rest of the system, so that, you know, when you power the system off, this is off, the Class D amplifier is off, and everything else. So let's dive into a schematic from here, because I've got this and I've got the PAM device, and I'll tell you what I'll do. Let's fire up a wee little bit of Vizio. All bought and paid for, I should add. Unheard of in this market. Let's have a quick look. And while Vizio is loading, what I wanted to show you, what I wanted to do was talk a little bit about the audio sources themselves. So let me, if Vizio ever catches up, I think my PC's busy encoding. And let me just check the health of the stream here, if you don't mind, very quickly. YouTube live dashboard, YouTube is happy, and I think people watching down to 2 users are happy, so I'm going to keep on rolling here. Alright, so here we're going to have our Raspberry Pi. I'm going to type as little as I can. Now, coming out of this, I was initially looking at using USB, like a PCM2704. And I fired it up. It works wonderfully with the emulators, passes audio really nicely. However, as soon as I fired up Quake 3, which is something I've been playing with my son recently, it would just crash it as soon as the level would load. And so I'm kind of becoming a little bit more agnostic to where the analog audio source is, because, you know, there's plenty of HDMI screens that you can buy. There goes the dog. There's plenty of displays out there that you can buy where there's an analog output on those as well, which is going to be better than the display output on the. Sorry, I'm just checking if my son's woken up or not. Yeah, there's plenty of those displays with analog out, so I could hook that into this as well. So I'm kind of compromising for now, but I'm sure we'll get over that with time and therapy. So I'm going to put then analog volume control here. Analog plot, and it's a stereo analog plot. Yeah, sorry dude, the dog's a liability in this house, but you know, I left the garage door open for 2 days once, nobody stole a single thing. I'm convinced it was the dog. So the volume plot I was looking at using, and I haven't got a library for this, will probably have to be something I'll have to do offline, is one of these little thumb wheels. And they are little stereo thumb wheels. I think this one's a 50K. And so nothing special to say there. I need to design a library for it. But the problem is I can't just put this in line with the headphones or just with the amplifier and so on. Because if I put it in line with the headphones, then I create a potential divider that messes up my my amplifier input. So what I actually need here is a buffer in between the analog output and the headphones and the amplifier. So what you actually end up with is something that looks a little bit more like this, right? So you end up with analog port, headphone amp, And oh Lord, that didn't copy paste well. Hold on. Here we go. This is the PAM 8403 speaker amp. Let me zoom in a little so those of you on poor displays can see this. And so what you essentially, this is also, I'm drawing it as mono, but it's actually in stereo. What we're actually going to see is a little bit of this. And this one's actually going to feed into here. So the headphone amp actually ends up becoming a bit of a buffer for me. And my jack connector is actually going to live, and I've drawn it really badly, but the jack is kind of going to live here. Typical. Alright, let's move that down one. Now I can get a connector from my jack. Let's see if I can, we'll just do a line from here that actually allows me to power on and power off my Class D amplifier. So that's the idea, right? It's analog port controls all of this, and this mechanical switch is coming on here. These are only going to switch on power-wise. We'll do the old school switch. Here we go. Along with, so we'll consider the DC DC boost converter here, and here is the battery. There we go. Professionally done, right? So the hold on, is my stream offline now, or guys, are you getting me loud and clear? Kind of getting paranoid here. Alright, it says I'm still live here, so I'm going to keep on trucking for a little bit, but if some one of you could confirm for me, okay, great, okay, so YouTube's being funny with me, no issue. Thank you, I appreciate that. Alright, so we've got this much done, let's just dive into Eagle. Christ, I spent so much time explaining, I'm better off just getting on designing here. Alright, so here's a over on the invisible left-hand side here, deep in the cosmos there, you've got your audio sources. We don't know if it has a DC bias or not, so the first thing we do here is we add a DC blocking cap, and then the TDA 1308. Yeah, I've noticed that, Adam, with YouTube generally there's a huge delay. I only look over at the secondary monitor once in a while just to see if anything's been said anyway. So I need to decide what the gain here is. The datasheet actually recommends 3.9 Ks. I need to see what's on my pick and place machine, because ultimately I do hope that I can here we go, that I can produce these and just sell them on the Expat Audio store just as a little kind of short production run. There we go, 10 Ks there. This here is a potential divider for the battery voltage. I'm calling it 3.7. It's actually 3.3. It could be 3.7, 4.2, and so on. But it's, you know, as long as Eagle knows what it's talking about, it's fine. And from there, we're going to AC couple out into the headphones. Now, 2.2 microfarads is a pretty small value of cap. And what I mean to say by that is, if you model the speaker as a resistor. Now, you know, it's not quite a resistor, but we'll just call it like this for now, just so I can share this with you guys. And Adam, you probably know this from your audio work at TI as well. What we've just created here is a high pass filter. Okay. Now, you know, in this case, this would be more like 32 ohms if I'm lucky, right? And so what I end up creating, in fact, let's see if I can do a high pass filter calculator. High pass filter calculator. Here we go. See if this works. In fact, TI used to have something like this as well, but I don't work there anymore, so I'm not going to push it too hard. Here we go, resistance. So we're going to put 32 ohm, and we're going to put 2.2 microfarad. And so the high pass filter created, come on then, chop, chop, chop. Frequency, 2 kilohertz. Crap. Okay, so I'm going to lose a lot of low frequency content, so I probably need to increase this up to sort of 10 microfarad or so. Let's see what 10 does for me. 10 takes me to about 400 hertz or so. I really need to be higher than that again. What a pain in the ass, you know. It probably would be much easier for me to Adam, I'll come back to your question in a second. I've just seen it there. Probably if I push this to 100, for instance, yeah, I would then crap. Where did it go to? Yeah, 50 hertz. That's a nice pair of headphones, but 100 microfarad cap is going to be too big inside the enclosure. I might put a couple of pins actually, just so if somebody really wants to kind of bend over big electrolytics, they could do that. That's not too bad an idea. Okay, so Adam asked, could you explain the drawbacks of a pre-existing Raspberry kit that does something similar? I haven't really seen that many Raspberry kits that do this. So I've seen Raspberry kits that have like a DAC that actually uses my old PCM 5102 and so on. I've seen some with like a 20 watt amplifier and so on. I've also seen, Adafruit does one with a Maxim I2S input amplifier that's about 3 watts. Great little part, 9 pins, just works. However, I didn't really want to get into that one because I don't have the headphone amp output then. So again, what I'm looking for here is that kind of laptop experience of, you know, volume control, analog controlled, so I can quickly turn it down when I need to. For instance, if the speakers come on too loud, I can just go whoop, turn it down, and so on. So hopefully that explains that. Now, if there are other ones, let me know. I mean, I think I can probably do it cheaper than they can, but then I can buy it, and you know what it's like. You know, well, Adam, you know me as well. I like the challenge more than the actual benefits of the actual product at the end of the day. Alright, so we've created a high-pass filter here. This probably needs to be a lot higher, so I'm going to put these in at so 10 microfarad. 10 microfarad, and I'm going to make a note for myself. Come on. Why is that doing that? Why won't that let me do a small micro? Okay, it's being a dick. Oh, no, I understand what I've done wrong now. I actually named the part rather than looked at the value. 10 microfarad, crap's rolling around, 10 microfarad, there we go, and we'll remove this and this. And what I'll probably do at this point is just tag these as specific signals. So we'll make one of these, a little bit of this, LS1, LS2, and we'll do, let's name them HPL and HPR. And what I may do here, just for skits and giggles here, is tie these, give them some kind of reference through a weak kind of pull down to ground, ultimately. So let's take ground from there, and we'll do another one there. I know, I should probably just connect them together, but no more questions from Adam. That's a good thing. Let's see how Twitter is coming alive with the sound of music. Hey, Sion, I really appreciate the push. Thank you very much. That's cool. Everybody else, keep promoting through your social networks and all that kind of rubbish. Alright, so that's that circuit. Now, here is my headphone jack, and this is a library I actually had made for me by a guy on Fiverr. I'm not sure how familiar you guys are with Fiverr. It's a great little sort of $5 or $10 service where, you know, if you're too busy to do a project or something like that, you can outsource it. And there's a guy there, Adam. $30 sounds to me where I'll be as well, or maybe 20 by the time I'm done manufacturing them. So yes, Fiverr. So I have a guy on Fiverr that makes libraries for me, and he actually makes them to my spec. So I give him a spec of all the data I wanted. Now I just email him like, hey, here's a data sheet. Make me a library. And so let me see if I can show you this one. So this is the. So this guy is called Mochini77. and everything's made for me as I expected. So for instance, you know, typical diagram, right? That's been ripped from the data sheet. That's not terribly complex. Oh, that closed, darn it. Package wise, I get a lot of details as well. Footprint, right, and typically linked to the data sheet as well, so I can find it later. And then let's go back here, the device itself, same thing, right? So I get, you know, the details about it, the email address of the guy, and you know, links to the data sheet. So with one click, let's see if I can fix this. What happened there? That's interesting. Normally these things work. Yeah, okay. Let's see if that will work. Crap. Okay, well, in this case, my example didn't work. Okay, lessons learned. Try these things before you show them. All right, so there's my. Let's go back in here, and so pin 5 and pin 1 here are my the ring, the outer ring, which is typically ground. So I'm going to borrow ground from here. There we go. We'll tie that there. And what I'm actually going to do here is tie this one through a high value resistor to my VDD. And I can hear you saying, guys, why are you doing this? Why? Because this is how I'm going to control the shutdown. So this signal essentially becomes let's give it a little, and one of these, we'll call it, no, come on, let me name it, shutdown. So this is the Class D amplifier, the speaker amplifier, being able to be shut down. Now that's the ring. So then I've got left and right. So I'm actually going to take pin 3 is going to be left, and the next one back is pin 2 is going to be right. So we'll do the same thing, and we will rename this one HPL. Yes, I want to connect them HPR. And I don't really care about the second ring back. So you've got the tip, ring, and then sleeve. And so the second ring back is typically only used for like headsets and things like that. And because I'm not using a microphone here, it's output only, just let it float. It doesn't do anything for me. So what I've got now is this signal, so that when it's open, when nothing is inserted here, this is going to be pulled high. And in which case that should switch on the amplifier. Alright, so let's have a quick look. Let's add the other amplifier now. Come on, there we go. Quick search. Yeah, alright. So I've got a library called Diodes Amps, and it's actually got the module, which I got from online somewhere, copied it and pasted it straight, and then the actual Class D amplifier itself. The modules are awesome, but there's no shutdown pin, as I said, so that's a real frustration for me. So in this case, I'm just going to grab the device, pop it down by here. Let's grab ground and just tie ground in where I have to. 1, 2, and 3. And actually AVDD and PVDD is all going to be the same as well, so we'll borrow this as well. And we're going to add like a bucket load of capacitance on this as well. And I'm actually toying with putting on, it'll come to me, a ferrite on the way in. Just to control any high frequency noise I have going into it, and to stop radiated stuff coming back as well. VREF needs to be to a cap, so we can do that quite easily. We've got caps here. I use 2.2 microfarad caps for everything. I've got reels of them. They come at about 12 or 15 volt rails, 0603s. Really, I mean, it's in my experience, and I've dealt with manufacturers building millions of product. I've dealt with manufacturers building hundreds of products. 2.2 microfarad seems to be this kind of like magic number. If you need capacitance that's higher, the price goes up significantly. But then the price of caps right now is a whole other weird space. I mean, there's only one thing that's weirder, and that's the price of graphics cards. So let's put that there. Voila. And I have in L and in R, so I'm going to borrow HPL and HPR again. Although I may want to you know what I'm going to do? I'm going to remove those for now. Or maybe I'll come back to it and just connect HPL and HBR here. Actually, I believe I need a resistor here. This is the time to read datasheets. So let's hop back. Where am I here? Datasheets. Yes, you see they have an input cap and a resistor. And RI sets the gain for the system. So I don't want too much gain because I'm going to be coming in with some pretty big levels anyway. So what we'll do is we will, yeah, you know what? I'm having a change of heart. Let's add those resistors back in, and what we'll do is it's going to be like a cap farm by the time I'm done. Is add these resistors on the inputs, and the value isn't important right now. There is a formula later on, which, by the way, one of the things I do in all my schematics is I actually write the formulas like on the schematic, so that later on, you know, when I'm like, oh, why on earth did I do that? There's some logic in my madness. Now, given the input impedance of this, I can probably drop these caps down to like 0.1 microfarads or something like that. In fact, the recommended schematic here showed 0.4. Okay. Alright, I'll just leave them as 2.2s then. I've already got the real of them, so who cares? People will be buying my board soon just to take off the caps I put on them. And RI needs to be defined, so let's just remove that value for now. Value TBD and another TBD. That'll help when I'm pulling the bill of materials and suddenly I decide, oh, what is that supposed to be? Let's have a quick look here. Rename these as HPL and HPR. So essentially what I'm going to do here is I'll tune the gain on this so that, you know, the maximum volume coming out of the headphone amplifier that's comfortable for the headphones I'm using, you know, matches up to like kind of, you know, 3 watts maximum output and so on. It just helps me make things a lot easier, I think. Shut down. Mute doesn't really do much here, so I don't really care too much about mute. In fact, I think I'll probably just tie the mute pin here. You know, in a proper audio system, I'd be really concerned about things like pop and click. I'm not really too concerned here, to be honest. If it's foul, then maybe we'll do something else. But okay, change of heart. Resistors are free anyway. Okay, let's have a look. Alright, shut down. Now, shut down when it's low. So actually, this signal, which is PAM shutdown, should work absolutely perfectly. PAM shut down. Yeah, named it right and all. Alright, so we're kicking butts, taking names. Let's have a quick look at the various social medias and so on. Make sure I haven't annoyed anyone. No, and Twitter is doing its Twittery thing. And YouTube has decided that it's still not showing me what I'm streaming, but everybody else is apparently, so that's fine. Alright, so now I'm left with out R and out L. And what I'm going to do here, very simply, is just simply bring them out to these, and I'll define a connector later on. So when I have connectors, I really try and keep them separated, because a connector never lines up beautifully on a schematic and looks like it simply connects very well to ICs. That would be nice, wouldn't it? Can you imagine if IC manufacturers actually spoke to connector manufacturers and kind of made it like nice, easy, straight connections? Ugh, you can dream, right? Let's change the name. No, name plus out L minus out L plus out R minus out R. Now this makes me wonder at the moment, a lot of these Class D amplifiers, they tend to spew a lot of noise around the place. And despite this PAM8403 claiming to be filterless, I am not quite as forgiving and believing as that. So let me have a quick look, see if I... here we go. How do I hide that? I can't. Oh, okay. Well, how do I hide the URL here? View, more tools, no, oh darn you. I really want to show you what I'm looking at, and I'm just wondering how I can do that. If I go into Streamlabs, go to Editor, and new scene. And yeah, I can't show it quite yet. That's really annoying. Alright, well, I actually have, screw it, why not? I actually have a little inventory server that I keep online. And so you can see here that, no, let's hide that, okay. You can actually see I keep track of all the products I have in my garage and so on. And this is something that runs on a Raspberry Pi that, in the UK. So I'm wondering if I have ferrite beads. And I do, it appears. I do have ferrite beads. This is an 0805 30 ohm 0805, and I've got a few more here as well, 60 ohm. Those are big old ferrite things. Ferrite bead. Let's see if I can get in here and see if I can get a data sheet for it. Reference only. You know what? I think I'm just going to throw it in. I can always change it later. If I put in an 0805 package, I can actually solder down an 0603. It's very hard to do it the other way around. So let's jump on here. Let's delete these traces and get me a ferrite bead. So let's add ferrite. Ferrite bead from Adafruit. That's nice. Oh Christ, it's through hold. Ferrite. Come on, dangerous prototypes. Alright, and those of you who haven't tried the F11 full screen mode, thank you, Adam. I'll remember that next time. Here we go, 0805, job done, tick in the box. Jesus Christ, look at the size of that package. That's what she said. One, we'll just put this one, 2, 3, 4, and we'll just drop these through here. Now the only other thing that concerns me at this point is the, these small ferrite beads do appear to be somewhat resistive as well, and so ultimately I'm going to end up dissipating power in them as well. So that's a little bit of a concern. That'll require a little bit more homework to see if it's a is it DC resistance, DCR is a problem. It shouldn't be too bad. I will add this here. There we go. All right, Adam, you're an apps guy for amplifiers. How am I doing so far? I'm a codec guy at heart, so that's going to be plus out LR minus out L plus out R. Oh, there's no plus. And did I rename that? Yes, I did. Okay, and minus out R. Yes. Okay. How are we doing so far? Okay, so pin headers. Pin headers. Now, SparkFun have an awesome library for pin headers. Why, you're wondering, why am I so excited about this? Let me tell you why. This is another, I wouldn't call it a secret of my success, but it's something I really think is pretty cool. Where are we here? SparkFun, that's what I was looking for. Sorry guys. It's Pinhead, SparkFun. Alright. So what SparkFun actually does is they don't make each of the pins universally spaced, because when you're trying to hand solder them and you turn the board upside down, the pins just fall straight out, and that's really, really, really annoying. Thank you, Adam. I just saw your comment there, disregarding all datasheet recommendations. Yeah. You know, a long time ago, we had a customer that was building home theater systems that didn't ground their soldering irons properly, their rework stations, and on the production line they were reworking boards, and their soldering stations were floating up at 70 volts, and they were just frying chips left, right, and center. Anyway, let's have a look here. Rocker, no, I don't want screw terminal, I want long pads. There we go. Alright, the cool thing about these pads is, and it's not really shown very well here, it's a pity, is that, there we go, is that they actually space them slightly far apart, so there's a little bit of a friction fit for the pins when you put them into the board. So when you flip the board over to solder, they stay still. You know what, sometimes it's the dumb stuff that's really cool. So let's just tie this here, tie that there. Look at that, these connectors did line up nicely. Oh, you bugger. Let's mirror this. And yeah, you know, it's funny, SparkFun started off really being kind of really innovative, really innovative, and Adafruit's just overtaken. Just at least that's the impression I see in terms of tutorials, in terms of you know, libraries and bringing stuff to market. It's just I would love to know what the revenue difference is between both companies now. That would be really interesting. And you know, Adafruit, it dawned on me the other day, Adafruit's really put their money down on distributors in local countries and so on, and even like at Micro Center here in the US, which is like a, you know, an electronic computer store, you can buy Adafruit products. Some really smart people, really smart people. All right, all this yak, it's making me thirsty for tea, and my tea's gone cold. Hold on, let's get it on the tea warmer here. Best gift ever from the wife. One of these little cup warmer jobbies, you know, mains powered, none of this USB nonsense. Oh yeah, perfect for keeping a good cup of tea warm. All right, so let's have a look at things. So we've got, let's float around the board a little bit here. We've got our audio inputs here. We haven't got our potentiometer. That's missing. Bad David. Need to work that one out. See if I can find a library for it online a little later after I'm done broadcasting here. Okay, so we assume we come out of the Raspberry Pi, so let's move some things around. Let's keep this clean. If I can get it on one schematic, it does help. Move group, we'll just move that down there. I'm wondering if I can just move these in a little more, just for housekeeping, you understand. Move that in, and ultimately that means I can move this down and make it just slot in here. Move group. Ha, look at that. Beautiful. And then the brains of the operation, the stuff I really lose sleep about, can be moved about here. and that allows me to put my connector for my audio from the Raspberry Pi, or whether it's from the Raspberry Pi, or whether it's from a USB DAC, or whether it's from a HDMI monitor or whatever display. I can pop that in here and bring it in here. Now, next question is, what's the connector? You know what? Let me just do this. I think that's going to be the easiest thing to do. I could put on like solder pads and so on, but yeah, ultimately, if I'm hooking into a 3.5mm jack, I'm going to have to make a 3.5mm to a 3.5mm to what you call it, you know, to bare wire. That's a pain in the ass and all. So yeah, we'll see how that rolls here. I need one of these. Okay, so let's go to here and fire AliExpress, because this is exactly where I buy most of my parts from. And we're gonna go for B503 thumb. Let's see what it finds. No, I don't want plants. Thumb wheel. Let's try thumb wheel. Ah, oh, you son of a... Ah, there we go. Look at that. Beautiful. Okay. So which one of these do you think is actually going to have some kind of datasheet? No, what's that? No, no, that's crap. That's all. Ooh, model number. Wheel. Okay, here we go. So let's see. This is 16 by 2. Do I have my... Here we go. Hey, Sion, does this look familiar to you? This is one of the rulers. I noticed it in your latest video. I was like, oh, I already have one of those. Okay, so this is measuring in at, yeah, about 16mm by 2mm. So let's do a Google for 16 by 2mm thumb wheel potentiometer, and let's see if we can find a reputable manufacturer of these. Thumb wheel Mauser PCB mount. Oh yeah, baby. So you know, the guys in China, they never manufacture anything creative themselves, right? They take somebody else's product like an Alps potentiometer and they knock it off. So what I tend to do is get the Chinese parts, work out who they copied, and look at that data sheet. I think the rest of the world does the same as well. Audio part, that's about type. Come on, wheel. Rotary thumb wheel. Oh yeah, baby. Okay. Apply filter. And come. Oh no. You son of a... These are all mono ones. They're 3-pin monos. But I now know the manufacturer, so let's have a look at Alpha Taiwan. Alpha Taiwan, not to be confused with Alpha USA. They are quite strict about who's who. Alright, let's have a look here. Taiwan Alpha. Alright, bending detection sensor, that's interesting. Anyway, we'll come back to that when I do some stuff on haptics. That's a whole other kettle of fish we're going to start playing with. Oh Christ almighty. Wire wound, special use, metal shaft, snap in, no. Here's a rotary type, there is a general type, and it's going to be 16. Hold on guys, I'm going to sneeze, let me make sure I can mute this in time. Hold on. No. No, fake alarm. I mean, you know what I mean. No, it's not one of these, you buggers. Honestly. Alright, let's have a look, see if they've got another 16mm here. 16 Uzi 16mm. Snap-in insulated shaft? Does that look like a snap-in insulated shaft to you? I don't think so. I think that's a lot of rubbish. Come on. No, okay. Let's go back to... Okay, Mauser screwed me over. Let's go back again, back again. No, too far back. Story of my life. Mauser. DigiKey. DigiKey wouldn't let me down, would they? We got a better collection. Come on, give me a stereo one. Oh, you son of a... Okay, how do I search? Active, side adjustment, round gull wings, PC pins. Come on. Okay, side adjustment. Let's try that one, see how that rolls for us. And what can I do then? Rectangular or round? Trim pot. Bonds. B1. Okay, this is B103. B103 stereo potentiometer data sheet. Come on. Christ, you guys are patient. Oh no. Getting there though, right? I feel like we are. Guys, if you can find this as well, let me know. Oh, come on, you son of a spanner. Amazon's about as useful as a chocolate teapot. What's this? Pick click. Helps RK online. No. I don't think I have to measure this one. Oh wait, no. Hey. Okay. New supplier. If you guys don't know about these guys, these are LCSC low cost like parts from China. They take PayPal, they ship fast, and they're the same people that do the JLC PCB. So that makes me very happy. Data sheet. Come on. Oh, it's only 3 pins. Come on, show me one where they have. Son of a... Come on. Alright, well, on that happy note, I think we're done for now with the schematic. Tomorrow night, or whenever I can get the wife out of the house as well, I'm going to start doing the layout for this, and hopefully by then I'll have created created this as well. So thank you for those of you that joined today. I really appreciate it, and appreciate the company, and I'll probably have to edit this down and cut out a lot of the mumbling that I've done, but appreciate you all. Thank you very much. Speak to you all soon.